Maybe it's because I had two windows open. Maybe that's why. I'm gonna close this. Sorry, just a second. My windows, my. Okay. All right. Here we go. Okay. So this is pretty typical. Only one of the parts is extreme value theorem, but altogether now, you are going to start to be able to do quite a few free response questions because you've learned so much calculus. The figure at left, I don't know the difference between left and right. Sorry, I meant the figure at right. Shows f prime, the derivative of function f for -4 to 7 inclusive. Graph of f has horizontal tangents at -1, 3, and 5. It occurred to me a little later that that 3 makes it look like that's the x value on the axis. That's not. That 3 is the area in that region, okay? The x value there is -1. Obviously, it's not x equals 3. Can't count. The areas enclosed are given, and f at 1 is 5. All right, all that stuff you'll use in terms. Trying to prepare you for every eventuality. Typically, the first question you'd be asked in this situation is something about using the f prime graph to talk about f. Now, it could be just where is f increasing, in which case you'd say where is the f prime graph above the x, the top. Okay, and boom, you got your f is increasing. You could ask decreasing, or you could be asked for relative max and relative min. All those would use the first derivative graph to make a conclusion. Would you do part A, please, in 2036? Go. You've done that many times, you should be good at part A. Okay. Ready? Okay. Mr. Short, did you find the minimum?
Yeah.
At what value of x is there a minimum? X equals 1 or yes, 1, sorry. Yes, I agree. Do you all agree that at x equal 1, f has a min? Because, what did you say for your justification, sir?
F prime goes negative.
Beautiful. Okay. Mr. Fulton, right next to you, do you have a max? At what x value? Okay, I agree. And your reasoning? All right, super. There is a third critical number. If they had asked critical numbers, there are 3. What's the third critical number? X equals 5. But is that an extremum? No, there is no sign change there, so it's not an extremum. So it's a possibility. If they had asked critical numbers, you would have had that as a possibility. All right. It's also pretty typical. They ask you to make some conclusion about f dub. That could be talk about the concavity or the inflection points. In this case, I'm asking, is there any inflection point of f? Answer and justify. Go. 1 minute. Listos? Haley, talk to me. Where are your inflection points? 1, negative 1, 3, and 5. I agree. F has, please use good grammar when you go to write this. F has inflection points at x equal negative 1, 3, and 5. And why did you say that? Because?
F double, which equals the slope of F prime, changes sign.
Beautiful. F double, which equals the slope of F prime. Couldn't have said it better myself. Changes sign. Not equal 0. Changes sign. It has to change sign. Okay? Smaller little questions. Those are pretty guaranteed. You sometimes are asked to combine those two, find where it's increasing, F is increasing and concave up, in which case you just put those two together and look for two conditions at once. It's also pretty common to do a tangent. That's about half the time you're asked to do a tangent. Would you please, given the F prime graph, give me what the tangent line equation to F is at x equals 7 and F. That's it. Okay? Try that one. That might take a little more time. I'll give you 2 minutes then. Feel free to ask your amigos for help. Want a friend if you need as well. Start with the basics. To do a tangent line, you need a point, a slope, and then you write point slope.
It says hint to find F points using
The graph isn't super clear about F prime. Just go ballpark. Use the graph part and then with a group. It's also good practice, even if you're not sure how to do all of it. For example, you can find the slope and not the point. Do what you can, and at least get some credit. Scratch and fight for some points.
Oh, F at 1. We know F.
The question is, should we use a definite integral? The answer to that is 100% yes.
We are trying to find 7. What F at 7 to. We have F at 1. So I was curious.
Yes.
Because it says to find F points using
Ready? Another 30 seconds. Good? Another 30 seconds.
Add 7 to 0. I thought you said 0. I think 0. And then
No.
okay, we're not right. How it works? No, it's 0. Okay, I'm so what am I doing? What am I doing?
Because if it only goes to 1,
Okay, we cool?
then that's 8.
Okay, big idea. Tangent line, you need a point, slope, and you write your point slope. Okay? So it's a three-part deal. The point is by far the hardest part. You're given f prime and you want an f point. If you're given f prime and you want f, then you must integrate. Okay, so we're going to integrate. Typically we use definite integral. What should I go from and to? 1 to 7. Okay, 1 because we're given it, and 7 because we want it. Under f prime would equal f at 7 minus f at 1, yeah? Now I start there every time, but there are many people that jump right to what you want, which is to say f at 7 is f at 1 plus the change. If I moved f at 1 over, wouldn't it be that, yeah? All right, now that's good calculus. I understand they're giving you the areas, and it's tempting to just throw 5 and 3 around, but show where the heck 5 and 3 are coming from, I beg you. F at 1 is 5, and the integral from 1 to 7 is from here to there, and that involves these areas of, should that be 80? No, yeah, 5 and 3. Do you agree? So did you get 13 for f at 7? And therefore your point is 7, 13, with justification of where that point came from. The slope, that's the easier part. How do you find slope? The derivative at 7. And reading the graph, I said ballpark, it looks like 3. You follow? Okay. Now we're ready to write our point slope form. Y minus what? 13 equals 3 times the quantity x minus 7. Okay? We good? All right. That is also review, though it takes practice. The last one is the big idea that we talked about yesterday. Okay? It says find the absolute max and min values of the function on a closed interval. I expect this work to be done nicely. I expect it to be starting with the EVT. I know Mrs. Cannon doesn't necessarily require you to write the EVT. I do this. That's how I was taught. I want it. Okay? You need to say that the absolute extrema, or min and max, must be at, or only at, what possible places? Endpoints are critical numbers. Okay? That is the only place the greatest possible value can happen, at a relative extrema or an endpoint. Okay? If I made a closed curve with endpoints, then you can see that the absolute max is at a critical number and the absolute min is at an endpoint. Those are the only places it can happen. It's something magical. All right? Now, you then have the critical numbers. Even in a problem like this where it's pretty obvious to you, you need to say the critical numbers are where the derivative is 0 or undefined, and report those. Where's the derivative 0 or undefined? Here's the derivative, so I just need to find the x-intercepts, right? Negative 2, 1, and 5. So your critical numbers are negative 2, 1, and 5, along with the endpoints, negative 4 and 7. All right? Those are the only possible places the absolute minimum and maximum could occur. Now we need to create a little tournament of champions. Find f at each candidate to see of those candidates which actually has the greatest possible value. The easiest one is f at 1 because they gave you f at 1, it is 5. All right? Now, I'll ask those students who came from Miss Cannon, would you guys create an integral defined function like this? Or would you just find each one separately, showing this basic for each numerical value? You do this? The other way? Me too. Good. Okay, cool. What? You would do this? Okay. And then you would just say, here's f at negative 2, and here's f at... That's fine. I personally show the calculation to each. So do you... let's first go here. We have 5 numbers that are possible min-max candidates. The 3 critical numbers, where the derivative is 0, and the endpoints, okay? You tracking? We need to find all F5 values. Now, one of them is given. F of 1 is 5, that's easy. I need to find all the others. I actually found F at 7 in the previous problem. F at 7 was 13, so I guess we have 2 done. The other 3, though, we have to do that same fundamental theorem, definite integral work to find the y value. So let's talk about f at, what do you want to find next? F at -2, cool. F at -2, how do you find it? Start a definite integral?
Yes.
From where to where? -2 to 1 of f prime, that equals f at 1 minus f at -2, yeah? So when I go to isolate f at -2, is it f at 1 plus the integral or f at 1 minus the integral? Minus the integral. Excellent. Okay. F at 1 is 5 minus the area or areas from -2 to 1. What are the areas, the signed areas from -2 to 1? Is it 3 below? Is it -3 or positive 3? It's -3 because that 3 is below the axis. So that's minus -3. So that is 8. You have to consider the sign of that region. All right, cool. What do you want to find next? We have 3 of them. Now f at 1. And we got f at 1. What else? -4. Cool. -4 the endpoint. That would be the integral from -4 to 1 of f prime. That's f at 1 minus f at -4. Rearranging that to isolate f at -4 would mean f at 1 plus or minus the integral? Minus the integral. Now be careful. It's 5 minus parentheses signed areas. What kind of signed areas from -2, -4, sorry, this should be -4. What kind of signed areas we talk about from -4 to 1? +2 and -3, yeah? So altogether 5 minus -1 or 6. Cool? All right. Last but not least, we have 4. We still need to find f at 5. Okay. F at 5 is 1 to 5 of f prime. That's f at 5 minus f at 1. Rearrange then, f at 5 is f at 1 plus the integral from 1 to 5, yeah? Substitute in 5 plus, and what are the area or areas from 1 to 5? Straight up just 5. So I'm looking at 5 plus 5 or 10. Or 5 plus 5, so 10 total. All right. Now, we said that the only possible candidates for a max and min are these 5. So we should be able to look at these for the greatest. What is the absolute max? Right there. Okay, now last but not least, make sure you answer the question. Does it say what is the absolute max value of the function or where is the absolute max value? What? They say find the absolute max value of the function. The absolute max value of the function is f at 7, which is 13, or just 13. The greatest possible y value is 13. You could say because it's the greatest of the candidates, or because 13 is greater than all the other stuff, 10 and 8 and 6 and 5. That's like saying it's the greatest of the candidates, yeah? Let's answer the other question. The absolute min value of f is 5 because it's the least of the candidates. 5 is less than all the others. Or again, you could, I wrote the inequalities, you could say in words because 5 is the least of the candidates. If that makes sense to you. Whatever makes sense. Okay? Are we cool? That's an absolute extrema problem. it usually involves a good deal of work, and it usually involves a good deal of points, 3 or 4 on a free response question. Okay. That should go well. The one below it is similar, but not identical. You should be good. Okay. Questions on, what do you got? What's the oldest thing you got? 61, 2, 3? 61. Questions on 61. I believe many problems have been worked and keys are posted, otherwise sometimes fail. 61 questions. 25 did I hear? 1 and 5?
20.
Did you say, did I hear that?
Yes.
1 and 5, 20. 27? Oh, there's a 27? Oh, okay. Man, I'm going for it. All right, here we go.
Yeah.
Piling it on. Social utility break. Here we go. Number 1. If you recall, and I apologize, I know it's been a while, so these might not be right at the forefront of your memory, but 61 number 1 says, I don't think it has it. I think it said largest possible right triangle area if the hypotenuse is 5 units. Now what kind of problem is this called in calculus? Find the largest possible. It's optimization. Okay. So you're trying to maximize the area. You probably want an equation for the area. What is an equation for the area? It's a right triangle, and so you know you can call this x and y or base and height, but wouldn't the area be base height divided by 2? Yeah. Yeah. Okay. Now that's 3 variables. That stinks. If we could get it down to 2, that would be better. What's another relationship they give you? Yeah, the Pythagorean theorem idea. So, does it matter which one I solve for? I don't see really why. I mean, wouldn't you agree height is the square root of 25 minus b squared? By substituting that in, then I get 1/2 b root 25 minus b squared, which is a good one variable equation, or one independent variable equation, yeah? Now I want to find where a prime goes positive to negative for max. What rule for derivatives do I need to use? Actually, what 2 rules do I need to use? Product and chain, yeah? First stays the same, 1/2 b. Derivative of the second. What's the derivative of 25 minus b squared to the 1/2 power? 1/2. 25 minus b squared to the negative 1/2 times the derivative of the inside via chain rule. Negative 2b, yeah? First stays the same, derivative of the second plus second stays the same. Derivative of the first, derivative of 1/2 b is just 1/2. Okay? Cool. Okay. Now the algebra. I need to find the critical numbers, which is to say where this derivative is 0 is undefined. If I clean this up, that's probably the part that you got hung up on if you had the equation. I could take a 2 out, and I would get something like negative what do we got there? Negative b squared over 2 root 25 minus b squared. Yay? Are you with me? Plus root 25 minus b squared over 2. Let's get a common denominator. What's the common denominator? 2 root 25 minus b squared. This one you didn't have to change. It's cool. But this guy, when you multiplied it by root over itself, it becomes normal. 25 minus b squared. Okay? Together, then, I get 25 minus 2b squared. All right. Now, certainly a prime is undefined if the denominator is 0, and so that would be at b equal what? What will cause the denominator to be 0? 5. Okay, but can b be 5? No, you wouldn't get a right triangle then. Okay, that would basically mean this triangle has to approach just flat. So that's actually a minimum area. That's a no. A prime equals 0 at x equals, solve that equation mentally, please, for b. 5 over 2 or root 2? Root 2. 25 over 2 square rooted would be 5 over root 2. I wouldn't do plus or minus in this case because it's a geometry problem. There's no negative base kind of thing going on here. So the only question is that a max? If I were to mentally say, does this go positive to negative there? For small b's, this would be positive, like at 0. If b was huge, this would be negative. So it does feel like I have a max there. That is a max. And so I answer the question. Freaking heck. Yes, it is. Go away. Okay. So the only question is, do they want what is the greatest area or what are the dimensions? And you can answer from there. Okay? If they want the greatest area, you still need to calculate there. Question 5. Is 5 still a question? Yes? Okay. Good deal. The equation of f. This is the new ones. These are the new ones. Ax cubed plus b. They give you f as this. F passes through 1, 5, and f prime at 2 is 12. Find a and b. Okay. To find two unknowns, you need at least two equations. You need to figure out how to use these two facts. If f passes through 1, 5, then that means that f is 5 when the x is 1. So that gives you one equation. 5 equals a plus b. The next one involves the derivative. F prime at 2 is 12 means in the derivative is 12 when x is 2. That gives you that equation. Now you should be able to solve for a easily. It's obviously 1. And if a is 1, then b is that's pretty easy. 20. Question of 20. Is 20 still a question? 20. That's your replacement problem. Let me paste this in. Okay, this is a bit of a humdinger, but it's good practice. Like I told you, this is a problem off a Calc 1 final from CU. Okay, here we go. So this is the thought process. Are you ready? There's a lot of thinking to be done here. Okay. H is polynomial. It's odd. What does that tell you? Symmetry about the origin. Odd is symmetric about the origin. H of 0 is 0. Any odd function must either have a vertical asymptote or pass through the origin. H of 1 is 2. Now, every point they give me is going to be worth 2 points, because if H of 1 is 2 and it's symmetric about the origin, that implies that negative 1 is negative 2. Okay? Next idea. This takes a little bit of thought. As x approaches negative 1/2, the y values approach negative 3/2. Now, that just means approach. Can I assume that there's an actual point there? You can infer there's a point there. If it's a polynomial, it must be continuous. Polynomials like x to the first or x to the third, they don't jump. They're continuous. And so the fact that it's telling me it approaches negative 1.5 is just as good as saying it is at the point 1.5 because polynomials are continuous, all right? So I have a point at negative 0.5, negative 1.5, which again implies a companion point, positive 0.5, positive 1.5, yeah? Tracking? Okay, so now I have 5 points. As x goes to negative infinity, y goes to infinity. Where's that point? That's end behavior. As x goes to negative infinity, that's over here, y goes to positive infinity. So left and up, it must be doing that. Which implies, by odd, it must also be doing that. Check? Now, that probably cooked you out because you said, wait a second, I thought I had points down here. Well, there's no reason I can't. Yeah, it's going to go up there. Okay? Last but not least, actually, now we're close to last. Sorry. First derivative, it's decreasing up to negative 1. Now, that actually makes sense. Decreasing to negative 1, increasing in this interval, that makes sense with my dots, and decreasing after. So I feel like that's going cool. Now, how in here, I'm feeling it's going to go like this, but let's read on to the last part. It says h double is less than 0 on these intervals. What does that imply? H double negative implies concave down. It's concave down from negative 1/2 to 0. That makes sense. And concave down from 1/2 to infinity. That makes sense. That means it must be concave up. Anywhere else? And that's okay. It's got inflection points at negative 1/2 and 1/2. You get the thought process? That's called curve sketching. Those are different. Okay? Do you need more practice on that before we test on it? Yes, it would be wise. Okay. 27. Is 27 still a question? Are you still awake? 27 after. I'll assume you're asleep. 27 is done. 24. Does somebody need 24 still? No. Okay, so no 27, no 24? Yes, 24? Speak up, sister. 24, here we go. Let's just scroll down here. 24. What is the f is defined only on 1 to 3. What interval is g defined? G, which equals f at x minus 2, which is to say it's the same shape, just shifted. What interval? What interval does that shift it right, left, up, or down? Right. It's x shifts go opposite, so it's right 2. So the first endpoint of 1 would be shifted right 2 to 3, and the right endpoint of 3 would be shifted right 2 more, which is 5. So that's a shift. Okay. Okay. Last chance on 27. Yes, it's replacement. That's yes. What about it? Yes, go for it. Oh, so okay. So if you didn't look at the answers online, then the answers are something like 27. You would find when this is increasing by finding when B is greater than D. I didn't have a calculator when I was doing this, so can you tell me when is B greater than D? Birth is greater than death on? Say again? 0.484? 1.68? Are you just playing on the court? You should speak up, sister. Okay? A. B. Population is increasing the fastest. This one's hard. Population is increasing the fastest when the birth rate is great and the death rate is small, right? The net rate, think about it then as when the net rate is greatest. What's the net rate of change? What two things go into the net rate of change? Birth and death. So when the birth and death rate is greatest, so I would actually graph F3 of the birth rate minus the death rate and then find the max on the window given. I didn't give you a window. Oh yeah, 0 to 1.8 decades. Okay, so do that and you're good to go. And then C. C is an FTC problem. If the population was 500 at time 2, how many at time 5? You would use the initial condition. The amount at time 5 is the amount at time 2 plus the change from 2 to 5. Which again, I didn't have a calculator on, so do that again. Okay? All right. 62 questions. Questions on 62.
Someone say one.
One? Yeah, speak up, I'm deaf. 1, 9, 25, 26, is that real? There's no 26. 7? There's no 30. 1, 9, 25, 7? Check. 1. The old optimization.
Okay, not me because I did it.
So easy. So you've got this downward opening parabola, y equals 12 minus x squared, yeah? And you're trying to put a rectangle in it. So question, should I make it wide and short, or tall and skinny, or should I make it somewhere in between to get the greatest possible area? Well, let's start with the question. What am I trying to maximize? Area of a rectangle. How do you find area of a rectangle? Base height, and the base is x or 2x? 2 x's. The base is 2 x's wide and the y high. Okay? Now what do I do? Find the y. What's the y-x relationship? Every time x and y are points on the parabola. So they're related by being points on the parabola. So I can put in place of y, 12 minus x squared, and call the area equation 24x minus 2x cubed. Wait. All right. To find the maximum, I need to find where a prime goes positive to negative. A prime is, that means x must be plus or minus 2. If not, we'll blow off negative 2. X could be at its least 0, and at its most the square root of 12, because that's where the parabola ends at the axis. So everywhere in between, say 1. At 1, wouldn't a prime be positive? And at 3, negative. So did I find a max at x equal 2? Okay, now the only question is, do they ask what are the dimensions of the rectangle, or what is the max area? What is the area? Okay, so if they want the area is 24x minus 2x cubed, so the area added x of 2 is 48 minus 2 times 8, or 32. The greatest possible area is like Okay? 9, is 9 still a question? Okay. 9 is a question. And, all right. Okay, 9, this is actually identical to AP multiple choice on 2008's exam. F is a function whose slope at any point is twice its x coordinate. Would you put that into calculus symbols for me? Translate. Slope at any point. What gives you that? F prime. F prime is 2x. Okay, the derivative is 2x. Cool. Okay. F passes through to 5. What is that? Okay. Now let's start here. If I have F prime and I want F, what should I do?
Integrate.
Integrate. If I integrate, F is the antiderivative of 2x, which is x squared plus c. How can I find out plus c?
Use the additional.
Use the addition condition. If 5 equals 2 squared plus c, surely that c must be 1. So f of x is x squared plus. Okay?
Oh, yeah.
All right, that's testing your verbal skills, your calculus verbal to analytical translations. 25, is 25 still a question? All right. 25 is, 25 is a butt kick of mother, I'll tell you what. Did you know that many schools teach U sub in algebra? It's true, it's true.
What schools where?
Well, usually in a college algebra course, quite frankly, not in a high school course. So, check this out, my friends. You're trying to solve this here problem. Forget the calculator stuff. You can do the calculator stuff, I hope. Okay? You're trying to solve this, yeah? To be 100% honest with you, if I threw this on the board in the math room, they would get it, but it would take a half hour before they worked out, remembered how to do it. It's just, but they have all those tools in their toolkit. They see them, they just have to dust them up. This is a mess. And the first time I did this, I wasn't quite sure what to do, but I started just flailing, okay? So I don't know about you, but I said, well, I could do this. Still not sure what that does me. Then I thought, well, at this point again, my thought process is I don't know what to do, but do something. Here's something I could do. Okay, still not seeing it, but I could clear the fractions. I could multiply through by an e to the x. Now, if I multiply through by an e to the x, this would be e to the x squared minus 1 equals 14 e to the x. Now, the minute I got here, I said, oh, I see. All right, that is a problem within a problem. Now, that's why you think U sub. The problem is I have this e to the x thing, but it's in a broader shell of a quadratic. And so to deal with those in pieces, you would use U sub. You would say, let U equal e to the x. So I can just focus on the quadratic component. If I did that, then it becomes this. Then I think, oh, I can do that. That's quadratic. Yeah? And it's not like this wasn't bad enough, but they gave me a quadratic that doesn't factor, so I guess I'm going to have the quadratic formula complete the square, which you prefer. Do you remember how to complete the square?
No.
Well, let's practice it.
No.
So, u squared minus 14u, it's actually using the quadratic formula. What would go here to complete the square?
49.
Divide by 2 and square, so 49. You must balance by 49 there, right? U minus 7 squared equals 50. U minus 7 is plus or minus 50 square rooted. So U is 7 plus or minus the square root of 50. Are you tracking so far? Okay, now, I dealt with the quadratic part of it. Now I'm ready to deal with the exponential part. If u is 7 plus root 50, then that means e to the x is 7 plus root 50. And that means x is, solve that for x, the natural log of 7 plus root 50. There's one answer. Done. If u is 7 minus root 50, well, then I have a problem because that's negative. And e to the x cannot equal a negative. And so that actually is a bogus solution. That goes nowhere. The only solution is log of 7 plus root 50. Okay? That was tough.
Yeah.
That was tough. All right. Number 7. Question on 7? Okay. Okay, gold is being moved or mined at a variable rate. How much gold is removed? So I would have to take rate times time, right? But because the rate is constantly varying, I'd have to do millions of rate times time calculations. So to get the total amount of gold, I would need to do tons of rate times time calculations and add every one. That's screaming fundamental theorem application. Integrating a rate of change gives you an amount of change. So if I were to integrate RT from the 3rd hour to the 6th hour, and that the function's actually not too bad. You could probably integrate this by hand. It's 7t to the negative 1st, which is the same as 7 from 3 to 6 of 1 over t. What's the antiderivative of 1 over t? Natural log of the absolute value of t from 3 to 6. So it's 7 log of 6 minus log of 3. They sometimes will play with the answer. What log rule could they use to put those two together? Yeah, log of 6 over 3. So I would expect maybe a 7 log 2. What are the units? Yeah, they're ounces per hour. dt, though, has hours on it, so it's ounces. Log of 2 is a little less than log of e, so it's a little less than 1. So I don't know. A little less than 7 ounces, I would go. You follow? Any other questions on 62? Say what? Oh, I taught this for 8 years. That's a pretty good number, too. Yep. 11. 10-4, good buddy. 11.
I think we knew that.
Okay, this is a great technique question. 2x squared minus 3x plus 4 over the square root of x dx. Pause for a numerical mini lesson. 1 plus 2 plus 3 over 6. Do you agree that should equal 1, yes? Is it acceptable in numbers to, if you have a sum in the numerator, to split it up into each one separately over the denominator? Is that okay? Are these two equal? Yeah, that's equal. What if it was, the original problem was 6 over 1 plus 2 plus 3? Is it okay to call this 6 over 1 plus 6 over 2 plus 6 over 3? That's a no. All right, so the takeaway is, if you have a sum in the numerator, you can split it into many fractions. If you have a sum in the denominator, you can 100% not split it into many fractions. That said, then, this, you're going to use that split it up rule and say this is the same as 2x squared over root x minus 3x over root x plus 4 over root x, and integrate each one separately. This is nothing more than 2x to the 3 halves integrated if I combine those powers, right? Are you with me?
Yes.
And this is the same as 3x to the 1 half. And that's the same as x to the negative 1 half. And then I could just crank out each by power rule, raising it by 1, by the power by 1, and dividing by the new. So this would be 2 x to the 5 halves times 2 fifths minus 3 x to the 3 halves times 2 thirds plus 4 x to the 1 half times 2 over 1 plus c. You follow?
Yes.
So if you have a numerator sum, you can split it. Okay, other questions on 62? Are they a little late on the old announcements, or is it just me? Okay, 62, checkity check. 63,
Wait, so what is Q 13 from 62?
too late, missed it. 15. I don't know what it is. Okay, 62, 15, is that the correct question? Okay, I quite frankly am astonished nobody asked about 23, because I feel like that was, there's no way you freaking remember that geometry, no way. But okay, whatever, you say, no, if you say you do. Y equals X. Nope, too late. Okay, do you agree this has roots at 0 and 2? We?
Yes.
So, if I talk area between the integral, or the parabola and the axis on -1 to 2, isn't that going to require 2 integrals because you have some above, some below? So you should be looking this as 2 integrals from -1 to 0 is normal f. Because it's positive y's, I'll get positive areas. But from 0 to 2, you've got to go negated f. Now whether you negate inside or negate outside is up to you. I'm just going to negate inside and call it the opposite, so the sign switch. After that, I should see the antiderivative, 1/3 x cubed minus x squared from -1 to 0, and x squared minus 1/3 x cubed from 0 to 2. And then I should see fundamental theorem 0 minus -1/3 minus 1, and 8 minus 8/3 minus, check. So 4/3 plus 8 minus 8/3.
Good morning, it's time for the daily announcements. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Today, we're not going to be able to go through all of them today. Red Rocks will be here in the building to present a tower. They have a cooperative program that leads into the Colorado School of Mines. Please go to the counseling office to sign up. Also, Girls Mentoring, their annual cookie celebration this Friday, and it will be in the cafeteria. Mentors will bring the frosting and mentees.
Use similar triangles 30, 60, 90 there.
Decorations. Please go on the website to read the rest of the announcement. Thank you.
I guess I sent you short. You're a genius. Have a lovely day, 61 and 2 are due. Yep, for Dan.
Can I have the note sheets in the top section yesterday?